Take one. Action. Cut. Take two. Action. Cut. Take three. Action. Got it.
So in this example, we see that Highwire is shooting a light beam to the top of the building, and we want to know, or the movie producer wants to know, how far should Highwire be from the base of the building. And in order to calculate this, we use trigonometry. We need to decide, first of all, what information we are given so we know which of our trigonometric ratios we use. We are starting with 41 degrees. And we know that from here we are given the side that is opposite, which is 150 degrees, and we are looking for the side that is adjacent. Because we are not looking at the hypotenuse, we automatically know that we are looking for the tangent. In order to solve that, we would set up the following equation. The tangent of A, remember, is equal to the opposite over the adjacent. So we set up, instead of angle A, we replace it with the measurement of the degree. So we would say the tangent of 41 is equal to 150, which is the side that is opposite, over X, which is the side that is adjacent. We then have to solve by multiplying both sides by X. And then since we want to move the tangent of 41, we would then divide both sides by the tangent of 41. We would use our calculator and we would get 150 divided by the decimal value for the tangent of 41. And that gives us that X is approximately 172.55 feet, or 172.6 feet from the base of the building. So in this example, I'm looking and I'm seeing that I want to find the missing side and I want to round to the nearest tenth. And I see that I'm looking for A. In order to start, I always start with the angle. In this case, it is 36 degrees. So in order to decide which ratio I use, I need to see what information I am given. With respect back to the angle that is 36 degrees, the side opposite is X, so I'm given opposite. And I'm also given the hypotenuse. Opposite over hypotenuse is the sine. So I say the sine of 36 is equal to X over 16. This now becomes an equation that I can solve using a calculator. I multiply both sides by 16, and I get that 16 times the sine of 36 is going to be equal to X. At this point, I use my calculator. I have to make sure that my calculator is on degrees, and I type in the sine of 36, and I get a decimal, and then I times it by 16, and my answer is 9.4. So X is going to be equal to 9.4. If I am looking at the next example, which is number 2, again, I want to find X and I want to start from the degree measure. The degree measure is 42, and I am given the side that is not opposite. I am given the side that is adjacent, and I am also given the hypotenuse. Adjacent over hypotenuse means cosine. So I'm going to say that the cosine of 42 is equal to X over 13. In order to solve this, I rewrite it as 13 times the cosine of 42 is equal to X. Again, I type it into my calculator. The cosine of 42 is equal to the decimal value, times 13. My answer is 9.66, etc. So it rounds to x is equal to 9.7. If I look at my next example, I see that here I am given, from the 50-degree angle, I'm given a side opposite and a side that is adjacent. I am not given the hypotenuse, which means that I am finding the tangent. So I say the tangent of 50 is equal to the opposite, which is x, over 15. I rewrite this as 15 times the tangent of 50. I type it into my calculator. The tangent of 50 times 15, and my answer rounds to 17.9. So in this example, I see that I have no hypotenuse, so I know that I am taking the tangent of 29 and making it equal to the opposite over the adjacent. In this example, when I have x in the denominator, mathematically I would multiply x by both sides and then divide by the tangent of 29. But when I have a variable in the denominator, all I need to do is rewrite the equation as such. In this case, when I do it in the calculator, I would take 12 divided by the tangent of 29. And I get 21.6 is my approximate answer. And x is equal to 21.6. And that is my answer for the minute.
Here's an example where we're going to be talking about using the sine, cosine, or tangent to find information in a word problem. So a fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill off from the floor? The first thing that we want to do is we want to look and we want to make sure that we are using the correct trigonometric ratio. So from the 7 degrees, we know that we are given something that is opposite and the hypotenuse. So opposite over hypotenuse tells us that we are doing the sine of 7 degrees, and that is going to be equal to y over not 5, because that's feet and we want to know inches. So we're going to multiply this by 12 to turn it into 60 inches. Now I'm going to rewrite the problem, and I'm going to have 60 times the sine of 7 degrees, and then I'm just going to use my calculator. And I'm going to make sure that my calculator is in degrees and not radians. If you have any questions about that, please see me. The sine of 7 times 60 gives me 7.3 inches from the floor.